Ambient light. So previously we saw this diffuse lighting model or this Lambertian term. If we render something, let's say this cube, with just this diffuse lighting calculation, it kind of looks like it's in this dark, empty, deep space. So you see this other face here, this is completely black if it's not facing towards the light source. So the light source is somewhere on the right of the cube, and the left face is like completely black. It's almost like it's not even there, like you can see through it. So this is not exactly what we want. And this is where ambient light comes into play. There is always, well, almost always, some ambient light around, unless you really are in this outer space and no stars are shining on your spaceship or your space cube. So if that's not the case, then there's always some ambient light. If you're in a regular room, you have a light source shining somewhere, then light is hitting different surfaces, scattering from these surfaces, hitting another surface, and there are these very chaotic paths that different photons take, and the light is like very chaotically scattered around. Now calculating this is extremely complicated. With modern technologies you can do it with ray tracing and path tracing. There are also some other algorithms that do it. We will see these in the later half of the course, but right now we just want something that would model this ambient light in a really simple way. So what can be done is we just add some small value for the ambient light. So here you can see it's our same model from before. We have this material diffuse, we have this light diffuse color, we have this n.l, so this was the diffuse term we had before, and now we add to it an ambient term. And just for this completeness, I've written this material ambient and material diffuse as two different variables in this equation, but they actually have the same value. You don't have a material that would reflect ambient light somehow differently than it would reflect diffuse light. So that's usually the same value. But the ambient light's color, that would probably be different than the light's, the diffuse light color. Because the diffuse light color, this is some light source that you have. Maybe it's like this yellowish bulb attached to the ceiling that is shining light into the room, but the room is green. So this yellow light, that's directly hitting something. This is yellow. But the ambient light, that's the light that's reflected off all of these green walls in the room. And so the ambient light here, that would be green. So the ambient light's color is usually different than the actual light source's color. So in this model you just add this ambient term to the diffuse term, and this gives you some ambient light on the areas where the diffuse light isn't directly shining on. So the L ambient is the average color of our ambient light. The material ambient and material diffuse usually the same, and this is the color of our material. These two cubes, you can see the left cube is what we had before, so this face is relatively black, and the right cube is now where I've added this ambient term, and notice that actually all of the faces here turn a bit brighter. When you implement this, you have to be a bit careful, because if you look back at the equation here, we have this n.l, and while this n.l works very well if the light is directly shining on the surface, it does become negative when the light is at the opposite side of the surface. So what is usually done, and often this is not even written in the equation, this n.l, the cosine, is clamped to 0, which means that you just take the maximum value of 0 and n.l. So if it becomes negative, then it's 0. And it becomes important here because otherwise, even though you have this ambient term, if this term becomes negative, the light is on the opposite side of a surface, then it would start subtracting from the ambient term and it would still be black, which is not how light works. So here, this term, you should just take the maximum of that and 0 if you're actually implementing this. So from this video, you should understand ambient light. There is always some ambient light around in the environment. It's quite hard to accurately model it, how the different light paths traverse the room. But there is a simple approach, and that simple approach is to just add this ambient term. You kind of guess the ambient color of the light in the room, and you just add it to your light calculations.